The team is Marcelo and me, and we did some work on tooling. So first, excuse the silly name. It's just like we had to come up with a name in like 20 seconds, so that's the title there on the slides. So on tooling, let's first talk about the common development workflow. So it's a very simple like building and testing thing that you usually do. And our tooling will be on those two specific stages. And Marcelo will first talk about the building stage. So please, Marcelo.
Yep. Hello. So some of the pains of building stuff, especially native code, is you have to set everything together to cross compile and create a ext2 file system. You have to create a bunch of stuff just to run your application, right? Sonodo helps a lot of this with this, but I think we can, I don't know, I tried to explore some other strategies. So yeah, basically this. So my idea was can we pack this in a simpler way? So I built a system, a Gentoo-based system with a cross compiler and a bunch of our tools to make this easier. So in here I do a Docker run with this Docker image, and then I have these scripts that build packages. We can build, there's a really big list of packages available. So in this case, I'm building BusyBox. Then I installed it in a root file system that I selected here. It's just a folder that's gonna accumulate all the packages that I want to run, including my own binaries that I compile myself, the DApp. And then I set up this change root thing that it's a Linux syscall Linux system that you can transfer your execution environment to this directory. So after doing this change root, I can execute native RISC-V commands. So in this case, I'm executing this command inside this environment, and it's running RISC-V code. So all the Linux system calls are being intercepted by RISC-V, by QEMU, and being reinterpreted and run on a host. So this makes a lot of the development easier. And after that, I did this command that packs this folder and creates a root file system from it. So you have a lot more steps where you can just jump in, run commands manually, and test stuff manually, and then you build your DApp for you. And together with a mock of the rollup driver, I think it's gonna be really cool. And now for the testing part, I'm gonna pass back to Coutinho.
Yeah, thank you, Marcelo. Yeah, it's very nice stuff. So this step was essentially building a machine. So now that you've built a machine, well, let's test it, you know? So let's start testing it. The first thing you need is like Envol, you need like a local blockchain, and then you need to set up all the private keys, you need to set up network, and then you deploy all like the relays and input boxes, and then you need to extract all of those addresses so they're available for your DApp. And then you deploy the DApp itself. Well, then comes the node. The node is actually not one thing, it's actually a bunch of them. You need to spawn up a Postgres, Redis, a dispatcher, the advanced runner, graphical server, indexer, you know, it keeps going. And then you have the server manager, which is gRPC. And finally, you have the machine where your DApp is, you know, so the previous step that Marcelo just showed us, it actually only appears on this very last thing. And the about this view is that for testing, we really only need a machine, you know. So although Sonodo gratefully handles all those crazy dependencies, and the node is being greatly simplified as we speak, and also for some kinds of tests, we want all of those services, like if we're testing front-end stuff, you know, we need the GraphQL and whatever. For a specific kind of test, we really only need the machine. So this is the tool which I realized I never thought of how I could pronounce it. It's like a portmanteau of test and CTSI, so I guess it's testsi, I guess. Never mind. This is a very tiny taste of it. There's a lot more features, but I won't show them now for privacy sake. But the highlights is essentially that you start from a built machine, and you can easily just get all of that because there's this all code that handles instantiating everything. It only depends on the Cartesi machine. It leverages Alloy. So this macro you see right here is from Alloy. It's a Rust framework. And this Rust framework does essentially a lot of the hard stuff, that you need. For example, this I'm generating this type, which is essentially just the bytes, and then I can just do ABI encode of that. And although bytes is a very simple thing to ABI encode, this can be arbitrarily complex. And yeah, that's it. You just generate an input and just tell the machine to run it, and then you grab the result of that. You can do inspects. Well, actually not yet, but you'll be able to do inspects. Currently, you have the notices and the vouchers ready for you. And yeah, so let me see if there's anything else I wanted to say about it. No, I think, yeah. So thank you.